Dear students, in the previous lecture I have explained how to use linear programming problem for make or buy decision in the area of operations management. In this lecture I am going to take another application of linear programming in workforce allocation. So, the agenda for this lecture is linear programming problem in workforce allocation. This problem, the reference for this problem is from the book Anderson et al. So, first what is workforce assignment? So, workforce assignment problems frequently occurs when the production managers must make the decision involving staffing requirement for a given planning period. What is the meaning of workforce? How to allocate the workforce into various jobs, okay? That is the meaning of workforce allocation. So, workforce assignment often have some flexibility and at least some personnel can be assigned to more than one department or work center. Such is the case when employees have been cross trained on two or more jobs. For instance, when sales personnel can be transferred between stores. I am going to take one problem, how an optimal product mix problem can be used for assigning workforce allocation. So, the problem which I have taken is how linear programming problem can be used to determine not only the optimal product mix, but also an optimal workforce assignment. This is an hypothetical problem. A company produces two products with the contribution to profit per unit of $10 and $9 respectively. The labor requirement per unit produced and the total hours of labor available from personnel assigned to each of the four departments are shown in this table. So, we are going to manufacture two products, product 1 and product 2. We are going to use four departments. There is a restriction total number of hours available for each department. This is going to be constraint. So, if you formulate that problem, so we are going to take decision variable P1 and P2. So, P1 represents unit of product 1 and units of product 2 P2. So, they maximize 10 P1 plus 9 P2 subjected to this 4 constraint 0.65 P1 plus 0.95 P2 less than or equal to 6500. So, this constraint I have formulated from the table which is given in the previous slide. I am going to solve this problem which is on the left hand side, I am going to get the result. Now, I have brought that problem into the Excel. I am going to solve with the help of solver. So, on the right hand side I have the problem, in the left hand side if you look at that, I have formulated the problem as usual our usual procedure. So, what is the that is D5 is the value of decision variable 1, that is a P1, E5 that is a changing cells, okay. There is a coefficient objective function, there is a constraint less than or equal to, and there is a right hand side also is there the limitations. Now, I am going to solver data, go to solver. So, already I have formulated. So, this is a maximization type, please solve. So, select answer sensitivity limits, press OK. Yeah. Answer report. So, the answer says that the value of objective function is $73,589.74. We got the value for P1, that is 5743.58. For P2 it is 1794. So, I have taken this screenshot of this solution, that is our answer report and sensitivity report into the PPT. So, I am going to explain the interpretation of this output in our PPT in the presentation. So, the left hand side there is a maximization 10 Pn plus 10 P1 plus 9 P2. So, here in the right hand side I have brought the screenshot of our solver solution. So, this is our final value. Here we are getting the value of P1 and P2. Okay. Here we can look at the problem here, how we are going to use. You see that there are two constraints. There is these are less than or equal to type. So, it is a slack variable. So, this slack represents there is unutilized resources. So, in coming slides I am going to explain how to use this unutilized resources. So, how we are interpreting this? We know the value of P1 is 5744. Actually, I have rounded it, but we should not round it off because there may be issue in sensitivity, but at present for only for our convenience I have rounded. But technically rounding off will lead to infeasible solution. Later we will be studying when we are studying about integer programming. So, rounding off is not possible, but here only for convenient I am only for example I have rounded. So, the value of total profit is $73,590. When you look at this output, department 3 are operating at full capacity and see this one, because the slack is 0 value, and the department 1 and 2 have a slack of approximately 1062 and 1890 hours. So, we would anticipate that the products mix would change and the total profit would increase when if the workforce assignment could be revised, so that the slack, that is unused resources, unused hours in department 1 and 2 could be transferred to the departments currently working at capacity. So, what we are going to do here, there are some unused resources, we are going to train the people who are there who are working in this department, and we are going to transfer to the where the resources are fully utilized. However, the production manager may be uncertain as how the workforce should be reallocated among the 4 departments. That is our agenda for this lecture. So, what we are going to do? We are going to take some unused resources and we are going to train that employees, and we are going to utilize in the where the departments where it is of working at full capacity. So, linear programming model to include decision variables that will help determine the optimal workforce assignment in addition to the profit maximization product mix. So, this problem is a simple profit maximization product mix. Apart from this, when we reuse these unutilized resources, that also will increase your objective function. Okay. Now, we are going to include decision variables for the workforce allocation. The production manager may be uncertain as how the workforce should be reallocated among the 4 departments. So, the linear programming model to include decision variables that will help determine the optimal workforce assignment in addition to the profit maximization product mix. So, we are going for profit maximization type. So, we can maximize the profit by knowing how many units of P1, P2 has to be produced. So, apart from this, the profit maximization can be done by selling P1, P2 units plus using the unutilized resources. The whole agenda for this lecture is, yes, we are making profit by selling P1 and P2, but there are some unutilized resources there in some departments. How that unutilized resources can be utilized and the profit, how the profit can be maximized, that is the objective. So, how we are going to do called cross training. What is a cross training? Suppose that company has a cross training program that enables some employees to be transferred between departments. Cross training means if the person is specialized one department, so he can be his skills can be increase, his skills may be updated and he may be eligible for working in other departments other department also. That is the meaning of cross training. So, by taking advantage of the cross training skills, a limited number of employees and labor hours may be transferred from one department to another department. That is what we are going to do. This is cross training ability and capacity information. So, this table says that there are 4 departments. From department 1 to this one, from department 1 and 2, yes, there is a possibility of sending a person who is working in the department 1 to the department 2 after reskilling. So, 1 to 3 also possible, but 1 to 4 is not possible. So, from the department 1 maximum 400 hours is transferable. Similarly, from department 2, you see from department 2 we can transfer some, there is a possibility of cross training and sending the workforce to the department 3. So, 2 3 is possible, 2 4 is possible. From the third department only one options, only 3 to 4 is possible. From the fourth department 4 to 1 is possible, 4 to 2 is possible. So, here how to interpret this table? So, row 1 of this table shows that some employees assigned to department 1 have a cross training skills that permit them to be transferred to department 2 and 3, that is why this 2 and 3 are yes. The right hand column shows that for a current production planning period, a maximum of 400 hours can be transferred from department 1. So, now we are going to introduce some more decision variables. Already we have the 2 decision variables P1 and P2, okay, in the product mix problem. Apart from this, we are going to introduce 2 more types of decision variables. Okay. So, when workforce assignments are flexible, we do not automatically know how many hours of labor should be assigned to or be transferred from each department. So, we need to add decision variables to the linear programming model to account for such changes. So, there are 2 types of decision variables. So, BI represents the labor hours allocated to department I for I equal to 1 2 3 4. Similarly, Tij, the labor hours transferred from department I to the department J. So, we are going to add 2 more decision variables. Very important point here, the right hand side are now treated as the decision variables. Okay, how? With the addition of decision variables B1, B2, B3, B4, we write the capacity restriction for 4 department as shown as follows B1, B2, B3, B4, that represents maximum how many hours we are going to transfer. So, here we are going to use the labor balance equations or constraints. Okay. The labor hours ultimately allocated to each department must be determined by a series of labor balance equations or constraints that include the number of hours initially assigned to each department, this one, plus the number of hours transferred into the department minus the number of hours transferred out of the department. So, this one. So, if any labor hours transferred to a particular department, we are adding plus. Any labor hours is moving away from that department, we are going to add minus. Okay. That is the meaning of this B1. So, when you look at this picture, what is this labor balance equation says that? So, this is the department, this is the department. If any additional hours is coming into the department, so we are adding plus. From this department, any hours transferred to other department, that is written as minus. So, the B1 equal to initial hours initially in department 1 plus this one, this plus hours transferred into the department. So, if any hours is going away from the department, the hours transferred out of the department, that has to be put minus. I will explain this concept with the help of a numerical value. So, this table shows that 500 hours initially assigned to department 1. See that initially for the department 1 we have assigned 6500 hours. So, we use the transfer decision variables Ti1 to denote transfer into the department 1 and T1j, okay, to denote transfer from department 1. So, what is this meaning is, so B1 I have written equal to 6000 plus, you see that from the department 4, okay, we are transferring to 1. So, T41 is plus, okay, and from the department 1 you see T12 is going away. So, it is T12 is minus 1. Similarly, 213 we are taking some employees from the department 1. So, whenever we are taking those, it is minus, that is why it is minus T13. So, when you simplify this, so B1 minus T41 plus T12 plus T13 equal to 6500. Similarly, for the department 2, 3 and 4, for the second department we have initially 6000 hours are allocated, that is why it is the initial hours allocated. The department 2, you see that from the department 1 it is possible. So, T12, so it is plus. Similarly, T42 is possible plus, but you see from the department 2 the people are moving away from T23, so T23 minus. Similarly, T24, that is also minus. So, now when you simplify, this is B2 minus T12 minus T42 plus T23 plus 2T4 equal to 6000. Similarly, by looking at the total hours available in the department 3, we can write the equations for department 3 and 4. Now, we have to add the transfer capacity constraint. What is the transfer capacity? From the department 1 T1 to T1 through, so that when you transfer it cannot exceed 400 hours from the department 1. Similarly, from the department 2, so T23 and T24 cannot exceed 800. From department 3, T34 less than or equal to 100, T41 plus T42 less than or equal to 200. So, now I am going to write the complete linear programming problem considering all decision variables. The complete linear programming model has 2 product decision variables P1, P2, 4 department workforce assignment variables, that is B1, B2, B3, B4 and 7 transfer variables. What are they? T12, T13, T23, T24, T34, T41 and T42, and there are 12 constraints. So, the complete problem is like this. Okay. Transfer constraint, okay. This is capacity constraints, this is capacity constraints maximum transferable. Okay. Now, we are going to solve this problem with the help of Excel. Now, I have brought the problem into the Excel. So, there are P1, P2, okay, product mix variables, B1, B2, B3, B4, the transferable variable, that and another the other variables. There are contributions there are number of units. So, I have written all the constraints. So, the resources utilized, the sign is mentioned, the right hand side is given. So, my objective function is in B21. So, now I am going to solve this one. Go to data, solver, solve it. Okay. Yes, now I got the solution value of P1, P2, D3, E4 and so on. Now, I will go to answer report. Okay. So, I have brought this answer report. So, our objective function value is 84,011.299. Similarly, I am going to sensitivity report. So, I have brought the screenshot of these reports into my presentations. From there, I am going to explain the interpretation of this answer in detail. Now, I have brought the screenshot of our answer. Now, we have here we have the value of P1, P2 and B1, B2, B3 and so on. Now, this is the value of our objective function, right, 84,011.299 dollars. The first inference is the company's profit can be increased by 84,011 minus 73,590 equal to 10,421 by taking advantage of cross training and workforce transfers. So, what is the meaning? Without cross training, this was 73,589.74 is our value of our objective function. Okay. After cross training, you see that the value of our objective function is now 84,011.29. So, the difference is increase in the value of objective function due to cross training. How much? $10,421 is the increase in the value of objective function due to cross training. That is the first inference. In the previously, without cross training, the value of P1 was this much 5,744. Now, you see that we are producing more products. Because of the cross training, there is an increase in product 1. Similarly, without cross training, the number of units produced is 1,795. Now, it is reduced 1,751, and this can be achieved by transferring T13 equal to 400. Where is the T13? We got this answer. That means, from the department 1, the person can be transferred to department 3. How much? How many hours? 400 hours. Similarly, T23, from the department 2, the workforce can be transferred to department 3. How many hours? Maximum 651. So, from the department 2 to the 4th department, 149 hours can be transferred. So, what we are inferring here, when we do the cross training, that the workforce can be re-employed in some other department, that will increase our value of our objective function. Okay. So, the resulting workforce assignment for department 1 to 4 is this one, 6,100, 5,200, okay, this one. Value of B1, B2, B3 and 4 up to B4. This is the first inference. If a manager has a flexibility to assign personnel to different department, the reduced workforce idle time, improved workforce utilization and improved profit should result. So, the linear programming model in this section automatically assigns the employees and labor hours to the departments in the most profitable manner. In this lecture, what we have done? We have taken a simple product mix problem. We have found what is our value of our objective function. Then we have seen possibility of transferring the workforce one department to another department, where we are transferring wherever there is unutilized resources is there, from that department. After cross training the employees, they are transferred to other departments where the requirement is needed. So, by transferring, we realize that the value of objective function can be increased. That is the outcome of this lecture. Thank you.